Attendees are in listen-only mode.
Hello, and welcome to the seventh in our series of Working from Home webinar series. Today we're going to be focusing on adhesion promotion surface treatments. Thank you for joining this Acculon webinar series. My name is Edward Hughes. I'm the CEO of Acculon, and today I'm going to be joined with Eric Brunner, who is the president and founder of Acculon, and also Mario Gattuso, our senior business development manager. From a logistical perspective, this webinar will be recorded. You will get an email later on today with a link to the recording as well as to a PDF of the slides and also a link to all the other webinars we've been putting on during this series. This webinar will be participatory, and so if you have questions, please go to the GoToMeeting question tab and type them in, and we'll try to tackle as many questions as we can at the end of the webinar. Again, thank you for joining us. I hope everybody is well and safe. Clearly, we are going through a pandemic that is enormous in terms of its scope, its speed, and the stakes that we're all involved in. What's encouraging and optimistic about this is people's ability to adapt. Everybody's having to adapt to working from home. And we as a company have had to adapt to a significant number of our people who are working from home. And during this time, it's given us the opportunity to focus on a number of things that we hadn't focused on, whether it's better processes, whether it's more innovation in our lab, which is operational, or whether it's putting on webinar series like this to communicate to our customers around the types of things that we can do. As a company, Acculon is a specialty chemical company and it's deemed as an essential company. And so we've been operating throughout this pandemic, supporting our customers, continuing to innovate. And today, we really want to share with you some things about adhesion promotion so that we're there for you when we come out of this. Our goal as a company is to enable our customers to make better products by being an innovative, responsive, and fast developer and producer of best-in-class surface modification technologies. Together, we create winning products. That's what we do. We help you create winning products. During this brief 30-minute webinar, I'm going to give you a quick overview of Acculon, talk a little bit about the technology platforms and surface modification options, and then really turn it over to Eric Brunner, who's going to take you through adhesion promotion, the technology behind it, some of the applications that we do in terms of in electronics, oil and gas, and in specialty markets. And then I'll talk a little bit about how we work with customers in terms of our lab service program, and then we'll try and tackle the questions. As I say, please type your questions into the question box, and we'll tackle them at the end of the presentation. As a company, Acculon is involved in many different fields. As you can see from this slide, we touch a lot of different areas, whether it's consumer electronics, whether it's oil and gas, whether it's medical devices, or a number of industrial applications. So we have a pretty good experience in a pretty broad variety of fields. As a company, we were founded in 2004. And really focused on developing an expertise relating to surface solutions to be able to modify a broad variety of surfaces, metals, glass, and polymers. That's really the core focus of our company, is to be experts on surface modification. We provide functionality to those surfaces, whether you're looking for repellency type applications, hydrophobic, super hydrophobic, oleophobic, or whether you're looking for hydrophilic type applications, anti-fingerprinting, and adhesion promotion, which is the focus of today's webinar. Our treatments are all very thin. They're easy to apply. We have simple equipment methodologies for application that do not require vacuum chambers. Often they don't require a cure. They're safe, they're non-toxic, and we offer green options. We like to think we differentiate ourselves from our competition by not only developing proprietary innovative treatments, but really the willingness to work with customers to help solve their problems. That kind of coordinated effort to help solve the problems is great. We don't believe in just throwing a treatment over the wall to you and saying, here, try this, and I hope it works. From a focus area, we have three kind of core businesses: electronics, oil and gas, and the specialty market, which includes medical and industrial type applications. Our business model is that predominantly we produce chemistry. We work with you to treat and qualify parts, to qualify the chemistry, but once that is done, then we'll be selling you the chemistry and you'll be applying it in your facility or in your contract manufacturer's facility to the parts. We have a strong IP base, over 35 patents. We've worked on thousands of applications and invested hundreds of thousands of hours building up this expertise in surface modification. We have over 100 products, and our people are smart. They are numerous chemists, PhDs, master's degrees, a lot of people with electrical and mechanical engineers as well. And we're based here in San Diego, California. That's where our headquarters is, our lab and our manufacturing facility. We have facilities in Shanghai, Singapore, Dallas, Amsterdam, and in the Asian markets, we have a number of distributors to cover those markets. So why does surface adhesion matter? Well, interactions with surfaces can create problems. So adhesion promoting technologies can be used to address a wide variety of problems. And I'll just give you 6 examples. So it could be an issue with the adhesion between the substrate and the adhesive is poor. You're not getting the bonding that you want. It could be you want to get rid of a step such as surface roughening, and there could be a chemical approach to doing that. It could be some of the traditional adhesion techniques are not viable in the particular process and the application you're looking to do. It could be that you are getting undesirable failures, right? Delamination, other things during a bunch of temperature or humidity testing. It could be that the current adhesion promotion process is too labor intensive and you're looking for something simpler to do that. Or it could be just you want to move to a different substrate, but that substrate has difficult bonding characteristics. So as a company, we started with our original technology, which is called self-assembled monolayer phosphonates. And that can treat a pretty broad variety of surfaces. These SAMP layers, monolayers as we call them, is basically comprised of a phosphonic acid and a repellent carbon-based molecule. And you can modify that functionality to basically be adhesion promotion or repellency. And what happens, obviously, the phosphonic head group bonds into that metal, has a very short chain, basically less than 5 nanometers in length. And that was a pretty flexible technology. But over the years, we've added a series of other platforms to basically broaden the suite of technologies you can apply to customer-related issues. Today, we're really going to focus in on one of those platform areas, and that's relating to adhesion promotion. As you can see, all our expertise and platforms relate to surface modification, whether it's hydrophobic, water barrier, oleophobic, particle treatments, anti-fingerprinting, hydrophilic, and today, we're going to talk about adhesion promotion. With that, let me turn it over to my colleague, Eric Brunner, to take you through some interesting slides on adhesion promotion. And he's self-muted.
Okay, there we go. Got the mute button off. Thank you, Edward, and thank you, everyone, for joining this webinar. I'd be happy to go through our adhesion promotion technology and give you some good examples of where it's been successful. Of course, adhesion promotion is really about improving adhesion, whether it's preventing delamination or just reducing adhesion failure. It's really an important space, and we can either do that by priming the surface, or you can use some of our materials as additives or adhesion promoters. In some areas, getting rid of roughening processes is important, especially in some of the electronic spaces. And the ability to have a flexible technology that allows a lot of different materials to be bound together is also very important. And those are some of the kind of core strengths of our technology. Next. So the first question we always ask when we're looking at a new adhesive issue is, what is the substrate? Is it a metal or is it a polymer? What kind of functionality does it have? And for metals, we've got kind of two platforms to work with. One is based on self-assembled monolayers of phosphonates or SAMPs, and we also have organometallics, which can react strongly with metals. On the polymer side, it's generally organometallics that we use. There are some other reactive chemistries, but that's kind of the first platform we start with. So the technology is it's a nanoscale technology. So most of our primers are typically going down in a thickness of 2 to 4 nanometers. And for adhesion, the main thing is to reduce any sort of failure at that interface. And so to prevent delamination, and we're doing this by bonding. So we want the chemistry to react strongly to form covalent bonds and really be a stable bond between the substrate and the adhesive or paint. And as we said before, the thickness is very thin, which is important, especially for some electronic applications where you're dealing with narrow bond lines, and you just really want to minimize the amount of material that's being used. And the powerful thing about our technology is it's got a lot of functionality. We have whether it's the SAMPs, we have 25 to 30 different SAMPs that we have that have different functional groups on the end, and then kind of a broad range of organometallics. So the technology is pretty versatile. What we like to call this the R group strategy, and it's essentially the next question after we ask what the substrate is what's being bound to the surface. And so once we know that, whether it's an epoxy or urethane or some other type of treatment, acrylates, we'll choose an R group that's got good compatibility that will react into that resin. And so we can play this strategy to pick the right functionality, or in some cases we don't always know what's contained in the adhesive, and so we'll just screen candidate R groups and see which one works the best. So this R group, or the kind of the tail that sticks out, allows us to really tune functionality. We also do a lot of repellency treatments, and so whether it's lubricity or making things easy to clean or just changing the surface energy, this tail allows us to really kind of change the functionality. And for adhesion, it's really the importance of getting a good interface between what's being bonded to the substrate. And then the treatments are generally pretty thermally stable. They're stable. Most of them are stable up to about 200 C. So this is a good slide to kind of show some tests that show just how strong our treatment really can be. This was a shear strength test that was done early on, actually, at Princeton University, where some of this technology came from, where we looked at bonding epoxy between titanium, and so we applied both a adhesion promoter as well as just a control, and you saw a pretty drastic improvement of shear strength, and we got shear strengths up to 70 megapascals. So for those of you that are kind of in the adhesive industry, you know just how strong that is. It's pretty impressive. And so that's just done by an Instron, where you have two coupons, you glue them together, and then you apply force and measure that force. Okay, next slide. So as Edward spoke to, this application process has got a lot of advantages. It's a liquid applied process, so you can think about it either being dipped, sprayed, wiped, dispensed. But all of these things can be kind of done in a continuous fashion, which is important to get away from. From cost standpoint, processing in a batch wise is sometimes a lot more expensive. So you can set up continuous treatment lines, and the main parameters we look at for the actual chemistry is concentration of the actives, what types of solvents we're using, where we need to cover the part, and then Most of the time, our primers can be applied at room temperature, but there are some substrates that do require a cure. So kind of the three main areas of the technology that are sold into the electronics market, into oil and gas, and then kind of what we call a specialty market, which is kind of all-encompassing. Electronics, we've had some good success, especially with lead frames. Lead frames have both epoxy mold compounds that are bound as well as die attach, and we've been able to significantly improve adhesion and with both mold compounds and die attach. Our treatments can modify basically all metals, including even gold, and so we've had good luck with adhesion of solder masks. We can also modify silicon, which is of course important in the electronics space. So our platform applies to silicon wafers. So digging a little deeper on the lead frame adhesion, like I said, it's good for both mold compounds and die attach. And this is really the main motivation is to improve moisture sensitivity level rating, which rates how well the package stays together in different temperature and humidity environments. And so we've been able to, in a lot of cases, increase the MSL rating of the lead frames and really, improve adhesion of both the die attach and the mold compound. Another space that's been really important in the electronics area is copper foil. We've been able to really help do a couple things. One is there's been a strong desire as the electronics have gone to higher and higher frequencies to reduce some of the roughness that was typically used to kind of get mechanical interlock of resins into copper. With our technology, you can remove a lot of that roughening, and so that has some good advantages. And then we've been able to, in a lot of cases, increase the strength up to 5x, which is great, and really help improve adhesion between copper foil and resins. Here's a slide that just kind of shows the peel strength results, and not only are you seeing the peel strength increase, but we're changing the mode of failure, which is, in the adhesive world, that's always an important question: is where is the failure occurring? And so whenever you can shift the failure from the interface into the bulk, where you're getting then cohesive failure, then your primer is really doing a good job. So you're just at that point limited in strength by the actual adhesive, not the interface. So in oil and gas, we've also had some success. There's some pretty extreme environments in the oil and gas space. Down well can be very hot, very humid, the adhesion can be very important. We've been able to help improve epoxy adhesion for a number of applications. Also, being able to treat sapphire and get a good adhesion has been important. We've done quite a bit of work on terms of functionalizing, whether it's oil containment booms or other, pipes or float sensors or, different substrates that kind of get into a relatively aggressive environment. So last and not least, we've got our specialty business, which is kind of a broad range of different things, both in in the medical areas as well as we've been able to solve some wheel weight adhesion issues. So we've the weights that go on the side of the wheel to balance them out. A lot of times with temperature and humidity and the new coatings that they're wanting to put on the wheels that provide kind of brake dust repellency also needed a real boost to keep those weights adhered. We've also got a number of medical applications where you've got dissimilar materials that are needing bonding. We've got nice success and good results in some packaging, also optics, and a lot of paints and coating adhesion to metal is important. Also particles. there's an interface between a particle and the resin. And so being able to modify the particle to be able to react with the resin can be very important. So with the wheel weight, this was really a problem that was created by putting, they wanted to coat the wheels to have a, kind of brake dust repellent treatment. It's, public information that Alcoa kind of led the way on this and developed a nice coating for wheels, but then they had unfortunately a adhesion issue, which we were able to help them solve. And it's easy to apply. We sell this product in a wipe form, so you just open up a prepackaged wipe. You wipe the section where the weight needs to be applied, and then wait for it to dry. It's basically about a 30-second process. You apply the weight, and then you get excellent adhesion. So I think we have some data to show on that, but it's really the key thing in a lot of these adhesion issues is looking at when the part or when the system is being stressed. And so a lot of times it's relative humidity, heat, and water can really interfere with good adhesion. Improving that bonding is important. So here's some of the results. You can see, especially when you're no primer versus our primer in a humid environment, you see a big increase of adhesion, and so ultimately, there's either thermal shock or humidity. You're really seeing the improvement by using the Aculon treatment. So with aluminum, we can apply our full range of adhesion promoters. One of the pushes in the industry is to try to get away from some of the chrome coatings, and we've been able to show that we can improve the adhesion of the beverage can liner to the aluminum, and so that's of course a big market. Tin-plated steel is also another good example. I mean, like I said, we can bond to all metals, including tin-plated steel, which is a important substrate for canned goods. Once again, there's a desire to really kind of get away from chrome and have good adhesion of the liner. And you can see with kind of one of the things we do with a lot of coatings is we'll stress the coating. We'll either put it in boiling water or in a chamber and expose it to moisture and heat, and then we'll crosshatch and do a tape peel. So you basically scribe through the coating, you apply tape, you pull the tape off, and then you can see whether or not you have good adhesion or not. And you can see with the illustration, the untreated side, you see delamination. You see the coating coming off on the side where you have the epoxy adhesion promoter. It looks perfectly fine. There's no delamination. So here's some other data that really shows, when you're in a stressful environment, you get with an uncoated substrate, a lot of times you get failures. And so when you look at whether it's drawing the cup, where you actually stress the system and making the can, or whether you're exposing it to, lactic or acetic acids or sulfide, you're seeing an improvement of adhesion. So that's both from a chemical resistance as well as mechanical. You can see a pretty drastic improvement if you get the right primer system. So again, on aluminum, there's a lot of aluminum that's used for parts out there. You want, a lot of it needs to be coated to protect the aluminum, and we're able to improve a lot of those coatings adhesion to the aluminum surface. And you can see once again another kind of crosshatch tape peel result, which shows very nice results. So here's some additional data shows that you start stressing the treatment either with Gatorade, Dalfax, coffee. You see a nice improvement pretty much across the board. In some cases it's just equivalent, but other cases you see a pretty nice improvement by using the Aculon primer. And particles, we've got some, basically any metal oxide or even some polymeric particles we can modify, and we can either alter their surface energy to improve the interaction between them and others, either resin or wherever they're being used. Most of the times it's an easy application. You can just suspend the particles in a coating solution, stir it, and wait for it to react, and then either filter or just remove the particles and then use them in an improved way. And so there's a lot of different applications for that, whether it's just filled paints or adhesives, or whether it's functional particles in a catalytic system.
Great, thanks, Eric. That was great. A lot of different applications. So let me switch gears a little bit and talk a bit about how we work with customers. Obviously, our goal is to help you hit the target. And as I said at the start, we are a company that likes to work with people, not just throw things over the fence and kind of hope it works. So we have a process we go through. So we start with really trying to understand the customer's requirements. So we're going to have a bunch of questions around what is it you are trying to adhere, what are the failure mechanisms, what kind of temperature or stress, as Eric calls it, would this particular application see. So we need to understand that. Then we will work in our lab to basically try different adhesion promoters to try and simulate what some of the things we're doing. In some cases, these tests are very customer specific, and so the test may need to be done at the customer. In other cases, we may be able to do them. So we'll try and analyze and characterize it. We then send obviously the parts back to you, or you'll test those parts. You give us feedback on that, and then we'll try to optimize it. We'll try to figure out, if it improved a certain amount, but you need it to improve on some other test. We'll see what we can do to optimize that. Such at the end of it, we basically give you a selection of the right adhesion promoter and a recommendation what to do, such that you can put it into a plant trial. And if we've done our job and we understand what you're trying to do, hopefully we can help you hit that target. So that's the process we go through. It's a relatively disciplined process. It's not one where we just throw things out and just hope that it works. From an IP standpoint and expertise, we've got this kind of combination I call hard and soft IP. We've got our grounded patents. We've got a number of trade secrets. We have treated and tested thousands of applications, and so that kind of knowledge that's been built up is pretty big. We have a great partnership with University of California, San Diego, that gives us access to millions of dollars of equipment, which is wonderful. And we've spent hundreds of thousands of hours solving surface problems and invested millions of dollars in building this capability and expertise. So we like to think, we've built this expertise so we can help our customers make better products. The other thing which is important to us, and hopefully important to you as well, is we want to be good stewards of the planet and try to offer our customers as much as possible environmentally friendly solutions so that you can support your sustainability goals, and together we can protect the environment. So we offer a number of options. We have VOC exempt options. We have PFOA free products. We use eco-friendly packaging. We try to make our transportation as efficient as possible. And even in our own facilities, we basically try to, be good stewards, and we've retrofitted all our lighting systems to basically, be LED efficient and use natural light where possible. So in conclusion, we are a platform technology company that makes customers' products better. Today, we talked about adhesion promotion. A lot of our business is relating to repellency, but collectively, we are surface solution experts. We have a strong history of working with customers to solve problems. That's how we win our business, by working with you to basically, solve the issue. We've got a broad portfolio of products, including many sustainable options, and we've got strong IP, great testing capabilities, and good in-house expertise. So I will thank you for listening. Let me pull up some of the questions and see if we can address as many as possible. Okay. Okay, so the first question is, and this one's for you, Eric, is can you explain what is going on with the will weight adhesion promotion? What what are we doing to the surface? I think it says polysiloxane coating to modify it.
Sure, yeah. What we're doing there is essentially applying a primer. So the wipe applies an organometallic material that reacts with the polymeric side of the wheel, and then provides a reactive functionality for the adhesive of the wheel weight to stick to. So it's just improving the adhesion of the wheel weight to the rim of the wheel.
Okay, good. Another one, it looks like it's some kind of automotive type question regarding, you mentioned about improving adhesion of the polyurethane coating. So what is the substrate you are trying to improve the adhesion to?
Sorry, can you repeat that again?
Yeah, I think it's a question related to another automotive application where you talked about thermal shock and you are improving the adhesion. I think it's the polyurethane to the underlying metal. Can you just explain a little bit more about what the metal is and what the thermal shock tests that were taking place?
Oh, okay. That's great question. Yeah, that is basically the automotive industry has started to set regulations or standards around paints needing to go through thermal shock requirements. So, you know, a lot of times it's like 85, so 85 degrees C, 85 humidity, and the paint needs to stay intact. It can't fail from the automotive part. So whether it's, you know, decorative trim, you know, like urethanes on, you know, whether it's speaker grills or decorative trim inside the car, just that need clear coats, they have to pass that thermal shock requirement. And so we've got a primer that can allow that urethane, whether it's a colored or clear urethane paint, to adhere to the metal and pass those thermal shock requirements.
Okay, great. Another question is, and again, Eric, you have to answer this one. You mentioned this can be done as either a separate layer or as an additive into this. So how does the additive work, and how much kind of loading do you have to put in?
Oh, that's a good question too. It really depends on the resin. There's kind of a range. It can be it can be as small as like a quarter weight percent to some of the loaded systems where you have particles in the coating. You know, a lot of times will take higher loading, so it could be all the way up to even like 5% add. But typical range is 1 to 2% by weight is the amount that's typically needed. Usually the exercise is basically to try the additive at different weight percents, and then apply the coating and look where you get the the best adhesion, and then choose that concentration.
Okay. Another question is, you mentioned that the thickness is only 2 to 4 nanometers. How do you control only putting down 2 to 4 nanometers?
That's a good question too. It's really the fact that the treatment is self-limiting. It reacts with the surface, but not itself. So therefore, what's the only thing that's really bound is the that first monolayer. And so you can either apply this in a real controlled way, or you can do post priming, some rinsing to remove any excess. But a lot of times that rinsing is not necessary. You get the bonding by the first monolayer that's 2 to 4 nanometers thick, and then any excess material just dissolves into the coating that's put on top of it. So, but the only real bound material is that first monolayer, and it's just because it reacts with the surface and not itself.
And these are solvent-based systems, so the solvent basically evaporates off, leaving that monolayer or the active. That's correct, right?
That's correct. Most of the time we're using solvents, alcohols or petroleum distillates. We do have some formulations that are in water as well, but yeah, it's a solution phase process where the active is in a solvent carrier. It reacts with the surface, and then the solvent evaporates, and you're left behind with the solid film that's bound to the surface.
Okay. Another question is, which metals require a cure?
Aluminum and titanium are the two that typically require a cure. If your aluminum's usually somewhere around 60 C to get the reaction to go, if you want it to go within a few minutes. If you're allowed to let the treatment sit overnight, you can get away with room temperature, but most industrial processes, they want the process to be fast, and so cure is used for aluminum. Titanium, we usually use a cure around 100 C. If you want it to go really fast, like 120 C. And then most other metals, it's room temperature reaction, and no cure is necessary.
Okay. And then there's a question around noble metals. You mentioned that these treatments can react with gold. I thought these metals were unreactive.
That's a good question too. Yeah, no, they are. They do have an oxide, and the SAMPs do react with noble metals. So we've got a lot of good examples of gold adhesion, platinum, palladium. We can react with the noble metals with these treatments.
Okay. The final question, you mentioned silicon wafers. Can you explain how you are functionalizing silicon wafers?
Really, it's the same approach. It's either using SAMPs, or we do have some silane-based treatments. Organometallics work as well. So we kind of have several different platforms to work with. The silicon wafer can be either dip coated, sprayed, spin coated, inkjet printed. Really, you can use your imagination on the technique, but they're all solution phase procedures to deposit the primer layers onto the silicon wafer surface. Great.
Well, thank you. I think that kind of wraps that up. We've run a few minutes over, so thank you for your questions, everybody. Thank you for your attendance. We hope you are safe, you are well, and if we can help you with adhesion promotion or other surface-related treatments, please reach out to us. Please reach out to Acculon.com, and we look forward to helping you make better products. With that, we thank you for your time and have a good rest of the day. Thank you.